Hello, everyone. Today we would be talking about beyond execution date and how it empowers inference execution and hyperparameter tuning with Airflow 3. My name is Rahul and I work at Astronomer.
Uh, my name is Ankit, and I work at Astroma as well.
So, when we say that beyond execution dates and how it helped like Airflow 3, so I would like to talk right with Airflow 3. One of the main goal of ours was to ensure how easy the adoption of Airflow we can make, right? So we work around all the issues and all the problems which we noticed can be a blockers or challenges in adoption, right? So that was our main goal. Now, in this particular talk, we would be talking about how empowering right and the execution date help us here, right? In terms of that, we would be not talking about what problems we solved. We would also talk about the proposal, right? And we would also talk about how we implemented and what are the roadblocks while we were implementing that. And we would be discussing more around that. Let's talk about the problem. So, what are the problems with Airflow 2 in terms of execution date? As you know, that each DAG run is tied to a specific execution date. And what that means is if we can have multiple DAG runs with the same date, we will get a unique constraint, right? So why it is a problem? The problem is it blocks a lot of workflows which can be essential, right, for the modern use case. One is event driven workflow triggers, right? We can have multiple triggers at the very same time, and if we do have those at the same execution date, those can be a problem with Airflow because it will generate a unique constraint issue, right? These problem is also can be related to inflexible for ML and GenAI workflows. And currently, there were some workflows and there were some workaround already in which people were hacking around the timestamp and trying to get it sorted with that, which we didn't want. So we wanted to solve it and we wanted to have the solution for this. And while we were looking for the solution, there was a Airflow improvement proposal 83 which talked around this, right? With that, there were two particular things which we wanted to solve. One was we would be renaming the execution date to logical date, and the other one was removing the unique constraint on the logical date. Let's talk more about that. Why to rename the execution date? So, most of the experienced Airflow users are aware that execution date does not mean the actual runtime, right? However, for new user, it could be a problem. As the name suggests, it kind of infers that it's the time at which the DAG run was executed, but that's not true. So we wanted that to be more logical and which reflect the better purpose. So that's why it was renamed to logical date. So that was the reason around that. And so while the implementation of this proposal, we removed the unique constraint and we noticed some challenges around this, right? It was pretty easy to remove the logical constraint. And when we noticed these challenge, these were very fundamental to Airflow and the way it behaved. And let's talk about couple of challenge. One was backfill. As you most of us know, right, that in backfill, fulfilling the date is something which we like care about, right? But let's say if there are multiple runs of the same date at the same time, how we will get to know what to backfill, how many runs to backfill? If we have specific multiple runs on a specific date, right? What we will clear, how we will clear, how many we will clear, do we rerun all the runs? So that is a problem. As with the earlier Airflow semantics, for every date, we can have only one run and one backfill can be proposed, which was not right with this approach. Also, there was a problem with depend on past, as many of you might know what depend on past is, but if not, we can use this attribute in the task, which basically infers the prior task and accordingly it runs. So if we have a prior on the prior run, we have multiple runs on the same date, which run to consider for this? This is also a problem. So whatever problems I'm discussing, they have the same root cause, but the challenges were coming from different areas. So one of the challenge was the XCOM retrieval. Let's say you want to retrieve the XCOM for the prior dates, right? But which run you want to get if they are on the same date, right? Accordingly, with Airflow UI grid, the it runs with the same dates were making a lot of confusion, and we did not want that. So after that, we considered that removing of unique constraints might not be the way forward. But in the same way, we have to also address the problem with Airflow 3. So the solution for that is we made an amendment with Airflow 383 proposal, right? And the amendment was that we will restore the logical date, and we will ensure that that logical date can also be set as null. Now, making logical date null solved all the problems which we were talking about, right? Which were blocking the modern day use case, event driven scheduling, which was blocking basically ML and GenAI use cases. Now you can have multiple runs right at the same time. You can just set the logical date null, which helped the use cases. Also, we had to introduce run after attribute, because let's say if you have runs with logical date null, how you will sort them on the UI. So with run after, we can have the run ID, right? And we can just append the run after field with some random string. So which becomes the run ID, and which can help us sort and get over with this problem. So these kind of amendment helped us go through with this. Now I will just hand over this to Ankit, who would be talking more about the detailed of technical implementation. He would be talking about more about the inference execution and different workflows.
Thanks, Rahul. So I think Rahul briefly kind of touched upon the challenges around AIP83 and how we fixed it. Just to give a recap, right? So what we did as part of AIP83 is we basically renamed execution date to the logical date. Second thing, the run ID right now is still unique across the diagrams, right? But the major change is like logical date is now nullable, and this change actually affects larger part of our code base. So we have rightly updated larger part of code base across API, CLI, maintaining the backward compatibility as well. Now, this, like I said, this is a big change. So how does this actually affect other Airflow features, right? So trigger tag run operator right now uses logical date, which can be null by the way right now. And API CLI require explicit logical date or none. Right, and similarly there are like templated fields. For example, there used to be DS execution date, right, which will error out right now if logical date is none right now. So this is an important thing to note for any DAG authors. Similarly, asset triggered DAG right now has an option to provide nullable logical date. And just to note, for runs with no logical date or data interval, there is a key error if these values are accessed through template or context, right? Now let's move on to what does all this change mean in terms of real world use case with respect to GenAI or ML, right? So one of the use case definitely is hyperparameter tuning. So just to like tell you briefly, hyperparameter tuning is just a process of running the same model training multiple times with different parameters, like let's say learning rate, batch size to find the best configurations. I'll show this with an example in further slides. But in case of Airflow 2, the problem was that each diagram needed a unique execution date. So to launch multiple experiments, engineers used to hack around with this fake timestamps. I can show you an example after this slide as well. But with Airflow 3, now that logical date can be none, you can launch and parallel runs cleanly, and each run can run independently without a timestamp collision. So this essentially makes Airflow 3 more ML friendly. So what I mean by that is, let's go with an example. So you can see in this example, this engineer just used an hack he specified execution date with date time now, uh, with and time delta to fake the uniqueness for each experiment he has been doing, right? So this makes it really harder to identify which tag run is associated with what kind of experiment he's trying to do. And it's confusing and error prone as well. But right now, he can just specify none, and triggering parallel run is straightforward and intuitive. And this is a cleaner way to do it. Now, let's talk about another important aspect, which is inference execution. So basically running a trained ML model on a new data to generate predictions. So oftentimes these requests are event driven and frequent. So like I discussed in hyperparameter tuning, uh, in Airflow 3, we had execution date, which was enforced on engineers to have this unique timestamp, right? Which was kind of blocking the multiple concurrent inferences at the same time. But with logical date being none, now Airflow permits you to trigger the same DAG multiple times with the same parameter. So this change, among many others, right, has enabled inference execution pipeline, and essentially the DAG can be a backend of any GenAI application as well. And I'll like show you this with an example and a use case in the next slide. So this is again the same example. You can see this execution date is not at all required, just enforced, and it's kind of meaningless in case of inference. But now it can logical date can be none, right? Now let's talk about basically architectural patterns you could adopt. And there are majorly two patterns in case of Airflow 3, which users can use to implement inference execution. So the first pattern is push pattern, and I'll go with an example use case in further slides, but just to give you a high level overview. So in push pattern, the external systems like let's say websites or API sends the post request to Airflow REST API. That essentially triggers a DAG run. So the user input is passed as part of a configuration payload as part of the REST API, right? And in the pull pattern, again, Airflow uses event-driven scheduling, let's say such as asset watchers, right? And it listens to the message queue. And for example, one could use Amazon SQS, right? And automatically a drag can trigger based on that new message whenever it arrives. So both the pattern kind of relies on the same logic, but the only difference is the triggering mechanism, right? So push is direct, but pull is event based. So now let me give you an example of let's say push pattern here. So let's imagine a use case. So let's say we want to let user request personalized AI generated content, like let's say customized newsletter directly from a website. So each time someone submits a form, it should instantly trigger Airflow DAG to process that request. So in this case, how it works is, so when let's say a user clicks the submit button, the website sends a post request to Airflow REST API. The form information is included in the request as part of the config data. Now Airflow then essentially runs a DAG which pulls the formatted newsletter from let's say S3 in this case, and then it would call any LLM or OpenAI in this diagram you can see, which would personalize the content for him, and then it would return the finished version to S3 and the website. So this is a push pattern, and in this case you can clearly see that Airflow acts as a backend for real-time inference or GenAI application. Now let's try to do the same using a pull pattern. So the goal is similar again, automatically generating personalized newsletter, but instead of triggering directly from user action. We want Airflow to react whenever new message arrives in the queue. So in this case, so when a website or let's say some other service places the message in the message queue, let's assume SQS as I was saying previously. So Airflow Asset Watcher continuously monitors the queue. So as soon as the message appears, it would trigger the same inference tag, right? So the DAG fetches the input, runs OpenAI call to create a personalized result, and stores it back to the S3. So the poll pattern is supports asynchronous approach, event-driven inference, right? And it is more suited for high volume or streaming workloads. So whichever pattern you use, the great advantage of Airflow as the backend of GenAI application is that you don't need to create additional backend component. You can essentially reuse the batch inference pipeline you already have in your Airflow environment for creating like near real time inference. And addition to that, you also get Airflow capabilities like retries or even observability in terms of seeing where the DAG is, what is the current state of your task, and so on. So that's mostly around it.